So let us now address the concept of thresholds. And the first thing I really want to do is I just want to write what this means in for you. So I suggest you do something similar and get this kind of definition down. We're going to define this as what I'm going to refer to as, and the pink stuff is kind of the key stuff here, a transition point. A transition point. And that's a term I really want you to get clear in your minds. A transition point, let me select the correct blue, a transition point where one source of energy, such as an energy system, one source of energy overtakes another. Overtakes with a different pink, I think. Overtakes another. I really must pay closer attention to which blues and pinks I'm using. Never mind. So we've got a transition point where one source of energy overtakes another. And I kind of really want to introduce you to two particular thresholds, which I think are absolutely critical for your understanding of training, of energy systems, of recovery. And they're these two. First of all, we have a transition point, which is approximately around 7 to 10 seconds. And this first transition point, it occurs because the ATP-PC system, declines. Now, and I'm going to graphically illustrate this for you in a few moments' time. But in the meantime, just expect from me that around about 7 to 10 seconds of high-intensity work, such as sprinting, say, or lifting something heavy, what we're going to get is that the ATP-PC system, which of course resynthesizes ATP in the presence of phosphocreatine, starts to sort of reduce the capacity at which it can contribute ATP. So we have a transition point then. And what also happens simultaneously is that the lactic acid system rises. And what we mean by that is that we're going to therefore get to a point, something between 7 and 10 seconds, where the lactic acid system takes over from the ATP-PC system as the dominant system producing energy. Now we can look at a very, very similar concept. And this time we're going to say that this particular threshold happens at something like 50 to 60 seconds. And it does depend on fitness and it does depend on the intensity of the exercise. But what we're going to find this time is that in this case, we're going to get that the lactic acid system declines. And this time we have a scenario where the aerobic system rises. So in this case as well, we've got a situation where not only do we have the switching between two anaerobic systems, which is what we've got here, we've now got the switching between one anaerobic system now to a dominant system being the aerobic system. So that switch and that transition is important because we switch into an aerobic mode. So let me actually put that in there. So we're going to say we literally switch to a predominantly aerobic condition. And you might be sort of considering straight away, well, if we're working aerobically at this threshold, we probably also need to reduce our intensity. Now, if you were to go out the door now and start running for 50 to 60 seconds as fast as you could, at around about 50 to 60 seconds, you're going to have to slow down because you're switching into that predominantly aerobic state. Now, where can we take this from here? What I'd like to do is I'd like to kind of introduce you to the main priority of training. So always, therefore, our training objective. What is always going to be our training objective if we are training around threshold periods, which, by the way, so many performers are. And our training objective is always, therefore, going to be to delay the threshold. So there's an awful lot of training as a big angle grinder starts behind me. There's an awful lot of training which is there and is designed to delay the threshold or delay one of these thresholds. Now what I want to do, and you may well have seen this illustration in other areas of my teaching, or indeed in your textbook or whatever, we're going to have a quick look at what we refer to as the energy continuum. So this in many ways is a little topic on its own, but I think it's nice to visit it now because it summarizes what I've just referred to. So let me do that for you now. Let me just drag down to here. Okay, so I'm going to draw in very loosely, very scruffily. I'm going to draw in two axes. Okay, so here on the x-axis, we're going to have time. So there's our time on the x-axis. And here on the vertical axis, we're going to have contribution. Let me spell that correctly and concentrate. Contribution to ATP. So we're going to be looking at which energy systems are contributing ATP and in what quantities. Now, this is what I'd like you to kind of figure out. I'm going to draw 3 curves in here. I'm going to ignore the initial 2 seconds of ATP breakdown itself. But what we're going to find is that we have this first peak. We have this first peak, and this line here is our ATP PC system. And what we're finding here is that we get a rapid contribution of ATP resynthesis by the ATP PC system, and then it dissipates. Now, as it starts to dissipate, of course, we're going to get something different. We're also going to have a situation where another system is going to be producing energy. And of course, what we've got here is we've got a crossover point, a transition point, and this, of course, is our transition. Or let me word it as I should. This is what we're going to call a threshold point. And I'd immediately ask you at what time phase you think that line is. And if your brain is screaming to you, well, I think, James, that's something like 7 to 10 seconds, you would be absolutely right. So, of course, this green line here, this is the lactic acid system. So we can graphically illustrate that around about 7 to 10 seconds, the lactic acid system overtakes the ATP-PC system as the predominant energy system. Now, finally, I'll do this in some kind of funky orange color. Finally, we have a third system which is going to contribute ATP, and it's going to work like this. In fact, I probably, if anything, I want to do that again, actually. So we have this third system. Now you're probably thinking that doesn't look much different, but this third system is our aerobic contribution. Okay, our aerobic contribution, and what we're finding here, of course, is that we have a second threshold point here. This is a second threshold point, and I'm sure that you will be able to tell me that this is around about 50 to 60 seconds of activity at around about this point. And we're finding here that the aerobic system, which this orange line is, starts to contribute more ATP than the lactic acid system. Now, the only other point I'd make to you, and you might want to sort of reflect on this, is that if we look at the total contribution of ATP, the total contribution of lactic acid system, or maximum, I should say, and the maximum contribution of the aerobic system, you might start to realize that, of course, by the aerobic phase, it's exactly what we said before, which is we have to reduce our intensity of exercise because we can only produce this much ATP with this non-fatiguing, long-duration aerobic system. So it's our ATP-PC system that produces the peak power lactic acid kind of intermediate, and the aerobic system is significantly less so, which is why we can do it for longer and sustain it in that aerobic condition. But those threshold points, as I stressed to you before, one at 7 to 10 seconds, where lactic acid system takes over from ATP. We actually call this the anaerobic threshold, and this one here, the aerobic anaerobic threshold at 50 to 60 seconds, where the aerobic system takes over from the lactic acid.